Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So today, teacher will discuss chapter 6, acid, base and salt. And subtopic 6.3, the strength of acid and alkali. And I hope after we discuss this subtopic, students should able to define strong acid, weak acid, strong alkali and weak alkali. And also, student able to explain the strength of acid and alkali based on degree of dissociation in water. Degree of dissociation and degree of ionization is same. Okay, darjah pengayonan and darjah penguraian. Okay, so before we start, look at this conversation, figure 6.12. The teachers asked the students about the similarities and the difference between these two acids. One student said both acids are monoprotic, and I hope you already know monoprotic is one molecule of acid produce 1 mole of hydrogen ion. And another student add hydrogen ion are produced when acid is dissolved in water. Okay, of course, when the chemical substance is acid, it will produce hydrogen ion. The presence of hydrogen ion will show the acidic properties. It relates with the rule of water 6.1, isn't it? Okay, and the girl said HCl, which is hydrochloric acid, is a strong acid, and ethanoic acid is a weak acid. So from this conversation, we found that there are two types of acid. The first one is a strong acid and another one is a weak acid. Okay, we start with the strong acid. Okay, so firstly, you should know definition for strong acid. Strong acid is an acid that ionizes completely in water to produce high concentration of hydrogen ion. Before this, you learn under subtopic 6.2, when the concentration of hydrogen ion is high, the pH value is low. Okay, the higher the concentration of hydrogen ion, the lower the pH value. An example of strong acid is hydrochloric acid. Other than that, we have HNO3, which is nitric acid. It's also a strong acid. Okay, hydrochloric acid is a strong acid because all the molecules of HCl that dissolve in water are ionized completely to form hydrogen ion and chloride ion. So look at here, we have hydrogen chloride gas, HCl. We cannot say hydrochloric acid because the physical state is gas. When the HCl is put into water, then we call it hydrochloric acid. Okay, so this is the molecule of hydrogen chloride molecules. Okay, when it's put into water, it will ionize. Okay, HCl will ionize and it will form hydrogen ion and chloride ion. And if you can see here, there are no more hydrogen chloride molecules. All already convert to hydrogen ion and chloride ion. So it means that the ionization is complete ionization. Semua molekul asid telah ditukarkan menjadi hydrogen ion and chloride ion. For example, kalau kita ada 100 HCl, we can get 100 H plus and 100 Cl minus. Okay, now move on to the weak acid. Okay, what is weak acid? Definition for weak acid is an acid that ionizes partially in water to produce low concentration of hydrogen ion. And relate to the subtopic 6.2, the lower the concentration of hydrogen ion, the higher the pH value. Okay, again, as the concentration of hydrogen ion is low, the pH value is high. So it relate with the subtopic 6.2. Example of the weak acid is ethanoic acid. Okay, and ethanoic acid is called a weak acid because the molecule of ethanoic acid only ionize partially in water. Ionize partially in water means mengion separa. Bukan separuh, separa. Okay, we look at figure 6.14. Here we have ethanoic acid molecules, when the ethanoic acid molecule is added into the water, ionization occur. Okay, and then ionization of ethanoic acid will produce hydrogen ion and ethanoic ion. So here we have hydrogen ion and here we have ethanoic ion. But if you can see here, there are more ethanoic acid molecules. Okay, lagi banyak ethanoic acid yang remain dalam bentuk molekul dibandingkan dengan yang ethanoic acid yang terion menjadi hydrogen ion dan ethanoic ion. This is because the degree of dissociation of ethanoic acid is around 1.14%. It means that if we have 100 molecule of ethanoic acid molecule, only one molecule of the acid will ionize to form ethanoic ion and hydrogen ion. And another 99 molecule remain as molecules. Means tak terion lah. Dikekal dalam bentuk molekul lagi. So hanya only we get one hydrogen ion and one ethanoic ion. Okay. So now this is the how ionizations occur. Okay, we have ethanoic acid molecule. Okay, ionize in water, produce hydrogen ion and ethanoic ion. And if we found here, there are reversible arrow. Reversible arrow means anak panah berbalik. Means that ethanoic acid molecule can form hydrogen ion and ethanoic ion. But this hydrogen ion and ethanoic ion can combine to form again ethanoic acid molecule. So maksudnya dia boleh bergabung dan menghasilkan semula reaktan dia, iaitu ethanoic acid molecules. Okay, now we move to the alkalis. Okay, alkalis. Alkalis, we have a strong alkalis, we have weak alkalis. Okay, so definition for strong alkali is alkali that ionize completely in water to produce high concentration of hydroxide ion. And for alkali, the higher the concentration of hydroxide ion, the higher the pH value. So the pH value higher. Dia directly proportional. Maksudnya when the concentration of hydroxide ion is high, the pH value also high. Example of strong alkali is sodium hydroxide. We also have KOH, potassium hydroxide, barium hydroxide, and so on. Okay, sodium hydroxide is called strong alkali because sodium hydroxide will undergo complete dissociation when dissolved in water, and by the end we only find sodium ion and hydroxide ion only. Means that the dissociation or ionization occur completely. So kita tak akan jumpa lagi NaOH. Semua already ionized and form Na plus and OH minus. Okay, look at this diagram. Here we have sodium hydroxide solution. Okay, after ionization completely occur, we found sodium ion and hydroxide ion, and there are no more NaOH molecules. So this means the ionization occur completely. Okay, so now we move to the weak alkali. Okay, definition for weak alkali is like equal to the weak acid, but weak alkali is alkali that ionize partially in water to produce low concentration of hydroxide ion. So the lower the concentration of hydroxide ion, the lower the pH value. Okay, so we already learned under subtopic 6.2. Okay, so example of the very famous weak alkali is ammonia solution. And if ammonia molecules ionize in water, it will form ammonium ion and hydroxide ion. Okay, look at this figure 6.16. This is ammonia molecules. Okay, when added into water, it will ionize, okay, and then form hydroxide ion and ammonium ion. But if you can see here, the the ammonia molecule is more compared to the ammonium ion and hydroxide ion. This is because the degree of dissociation of ammonia molecule is 1.3% only. So if we have 100 molecules of ammonia molecule, only one molecule of ammonia will receive the hydrogen ion from water molecule and form ammonium and OH minus. Means that another 99% of molecule remain as ammonia molecules. Okay, tak terion menjadi hydroxide dan juga ammonium. That's why lah the concentration of hydroxide ion here is low. Okay. Okay. So, look at activity 6.3 in your textbook. So, I hope you should able to relate the concentration of hydrogen ion and hydroxide ion with the degree of dissociation of the acid and alkali. Okay, if the degree of dissociation is high, the concentration of hydrogen ion and hydroxide ion also high. If the degree of dissociation is low, the concentration of hydrogen ion and hydroxide ion also low. Sebabnya kalau pengionan lengkap, maka kepekatan hidrogen ion dan hydroxide ion juga akan tinggi. Kalau pengionan separa, degree dissociation dia rendah, maka kepekatan hydrogen ion dan juga kepekatan hydroxide ion juga rendah. Okay, so you also should able to do test yourself 6.3. Okay, what is the question? Firstly, you should know the meaning for this following: strong acid, weak acid, strong alkali, and weak alkali. And also, you have to know why ammonia, which is a weak alkali, that has same concentration as potassium hydroxide, which is strong alkali, have a lower pH value. And what is the relationship between the pH value and the concentration of OH minus ion? Okay, question number 3. The pH value of 0.1 mole per dm³ nitric acid is different from the pH value of oxalic acid. Explain. So, firstly, you should know what type of nitric acid. So, nitric acid is a strong acid. Oxalic acid is a weak acid. Okay. And also, you should know how to relate the concentration of the acid with the strength of the concentration of the hydrogen ion with the strength of the acid. Then you should know the answer. For example, this type of question, the mark provided is 4 marks. It also goes to question number 2. Okay. So I think that's all for today. Thank you, everybody.